Alright guys, so I'm going to try to have a little video screen of myself as well today. We'll see how it goes. I may not like having my face on the screen all the time, but at least it'll be a little bit, maybe a little bit more personal. Maybe you can actually see Mr. Harrison and it won't be as weird as just watching a pen move around on the screen. But today, what we're looking at is solving linear systems. So again, we are still looking at linear systems. That's a big key. Using a different method other than graphing. So you may be wondering, why in the world would we even care about something other than graphing? It works, Mr. Harrison. I get the point. It gives me a solution like we've done before. Wow, look at there. Look at my pen doing fun stuff. But when we are looking at systems of linear equations, what we may run into is, and I know you guys, it gets on your nerves when I come back to this example a lot, but you look at that example with Mr. Harrison's gym, we've got really, really big numbers like 4,050, 90x, 75y, and then we still, even the other equation, x plus y equals 50, graphing something like this without technology is just going to be a pretty big hassle. And when it comes to inequalities, that's a major issue because in order to solve inequalities, you do have to graph them. So what we have is we have other methods for solving systems of equations. Instead of having to use graphing to solve this particular system, I can use a method that's called the substitution method. We're also going to look at another method called the addition method, but we're probably going to split that up into another day. I'm going to try to take these into kind of bite-sized chunks. You guys, I'm listening to your feedback a little bit. I won't be able to do this every time, but you guys said you like the smaller videos, so we'll try to keep it as short as possible. So the substitution method, what the substitution method is it is a way to solve that system of equations. You still have the same three possible answers that we talked about, where you could have one solution, no solution, or infinite solutions, where you have consistent and independent, inconsistent and consistent and dependent. Those are the three types that you have for linear systems. You can have the same thing with the substitution method. The difference is you are not graphing. Okay? I think I've said that enough times by now, but I just want to make sure you understand that. So in step number one, and by the way, you can copy these down if you want to. You don't have to. I'm not going to force you to. But if you want to copy them down in your notes, then you can. Just pause the video. Step number one, we pick a equation, to solve for one of the variables. It doesn't matter which one. So in step number one, don't think of it as graphing. It doesn't always have to be y that we solve for. Sometimes we're going to solve for x, and that's going to work just as easily as solving for y. So we pick a variable. So in order to show you what I mean by this, let's go to our first example. I'm going to kind of come back and forth between the rules directions page and an actual problem. This is the first problem. If you want to pause the video and copy it down real quick, you can. And then we're going to go through this together. So step number one says, pick one of the variables, pick one of the equations, and solve it. It doesn't matter which variable, it doesn't matter which equation. But hopefully you guys can look at both of these equations and see that the one on the top is easier. It's lower numbers. The y is almost by itself. The only thing we need to do on that first equation is get y by itself by adding x to the left-hand side of the equation and adding x to the right-hand side of the equation in order to get it off of this side and move it to the other side to get y equals 1 plus x. So step number one is just like what we do when we're graphing. We get a variable by itself, but it doesn't have to be y. So don't get roped into it's got to be y every time. So that's step number one. Step number two says substitute the expression from step one into the other equation for the variable that you solved for in step one. Now that sounds like a bunch of blah, 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 right? But look at what you got on the right-hand side of this equation. You have this whole thing, this expression, as the rule stated, that is equal to y. That means it literally is the same thing as y. Now, what it also means is if we take that and we want to know where the other equation also equals that, what we can do is we substitute this in to the y in the other equation. So let's step back for just a second. Let's talk about the word substitution. What does substitution mean? Well, think about a substitute teacher. It means, luckily, Mr. Harrison's not there that day, right? You don't have to deal with me. You don't have to see my ugly mug, right? That means you replace me with a substitute. So if this is y equals 1 plus x, we are literally replacing the y with 1 plus x. So what it's going to look like is 2x stays the same, plus stays the same. But where the y is, now we're now going to put 1 plus x from the other equation. Sorry about the bell again, guys. I timed these awful. Let me pause it for just a second in case there's announcements. All right, so I paused for a little bit. We'll see if I don't get interrupted. We'll see. So we've got, it's like a normal class, right? You know, we always got to have interruptions. You know, whether it's I don't know, Peyton back there doing weird stuff, or I don't know, people just blurting out different things that they shouldn't say maybe in class. Okay, sorry guys, way off topic. I'll shut up. All right, so anyways, so we'll look at now how to complete the next step. So once we plug in 1 plus x to this y, what we're looking at there again is we are substituting it in because it's equal to y. The big important thing is that you do not plug this into the same equation that we started with. So don't go back up here to the first one. You always make sure you plug it into the second equation or let me rephrase that, to the other equation that you did not solve in step 1. So if you'll look at the steps, it'll say that right here. It says substitute the expression from step 1 into the other equation for the variable that you solved for in step 1. Step number 3 says solve this new equation for the other variable. So in other words, look at this red equation right here. This equation only has x's in it now. And you can solve this by adding 2x and 1x together, because that's 3x. Now some of you may be saying, Mr. Harrison, what's the parentheses? Why'd you do that? We're going to come back to that on the next problem, but think about it this way. If there's a number in front of this y right here, I can't change it. I'm only changing the y. So if there was a number in front of it, I'd have to watch out for distributing that number. We'll look at it in the next problem. The plus 1 is right here, and I have a negative 2 on the other side. 2x plus 1x is 3x plus 1 equals negative 2. Then I just solve this just like I normally do. I subtract 1 here on both sides. That's going to give me 3x equals negative 3. I divide by 3 on both sides, and that gives me x is equal to negative 1. Now think about that. That is one of my answers. X is negative 1. I just need now my y value, because remember, we're looking to see what point do these lines cross each other if they do cross each other. So how would I get the y value? What you do is you take now this negative 1 right here, and you substitute that into this other equation. So let me go back to my steps. Step number 4 says substitute this value from step 3 into the revised equation from step 1 and solve. So from step 1, we look at that equation that we had. It's y equals 1 plus x. But now we know what x is. So essentially we're taking that first equation, when we find it, we're taking that it's equal to, plugging it into the other equation. Then after we've done that, we take the answer that we get from that equation to plug it back into the first one. In other words, we know now that x is negative 1, y is equal to 1 plus x, so y has got to be equal to 1 plus negative 1. Now remember, what this is doing is finding where these two equations are the same, what point they both hit. So we're not just pulling this negative 1 randomly out of somewhere. We are setting them to be the same by this substitution method in that first step. So 1 plus negative 1 is 0. That means x is -1, y is 0. If you were to graph these two lines, that is the exact point where they would touch each other. If you wanted to know the names of this one, it would also be consistent and independent, because that means they have one solution where they touch each other. So it would be the same thing as this. We just didn't use graphing. We used the substitution method. So that's the substitution method. So what I'm going to do is I'm going to go through it a couple more times with you and show you what it looks like, and then we'll practice some more tomorrow in class together. So let's look at another example. Oh, by the way, step number 5 down here says you can check the solution. Remember, you can always plug it back in to see if it works. You don't have to do number 5, but if you plug in -1 here and 0 here, you'll get 1. If you plug in -1 for x and 0 for y in the second equation, you will get -2. All right, so let's look at another example. Here's another example. Write it down. So if you want to kind of try this piece by piece, you can always pause the video and try the whole thing by yourself if you want. Or you can look right here at this first one and just try a spot of it and then pause the video. For instance, which one of these equations is going to be the easier equation to solve for one of the variables? Now I know the top equation looks pretty simple, but look at the second equation. It would be easier to get x by itself. So if you look at that, it's just a regular old x. I can add 4y to this side and add 4y to the other side, because it'll cancel it out and move it to the other side. -1 plus 4y, we can't really do, remember? Now, some of you, again, may be looking at that saying, no, Mr. Harrison, you have to solve for y. You have to. No, you don't. When you are solving for y only, that's because we're maybe intending to graph it. We're not graphing this one. So it doesn't matter what variable we pick. Step number 1 just says solve one of the equations for one of its variables. So if I solve the second equation for x, now I have all of this crap right here. Sorry, math word, expression, -1 plus 4y is equal to x. So the second step of the substitution method says take this right here and plug it all the way in the other equation, not the same equation again. Think about this. Let's use our brains for a second here, okay? I know that's tough for some of us, right? We take that equation. If we put it back into the same equation again, it wouldn't help us. Because if we plug one equation into the same equation again, that means those two equations would be the same. You would be getting the infinite solutions, those two lines that are the same all the time, always together. Remember our little funny example, two boyfriend and girlfriend that are stuck together all the time, okay? When you look at that, that right there is not what the answer is always going to be. It may be sometimes, but it's not going to be the answer all the time. So what you have to make sure is that you plug it into the other equation. All right, again, pause here if you want to try the next step on your own. But I'm going to plug this into here. So notice the 2 stays the same. I put -1 plus 4y where the x is, but the 2 didn't change. 2 is still multiplying times that x, because all of this is equal to x. The plus 2y doesn't change. The equals 3 doesn't change. So then solve this equation right here. Think about what you would do with that 2 first. Solve that equation and get y. Again, if you want to pause it and try it, pause it and try it. 2 times -1 is -2. 2 times 4y is 8y. Then I have this plus 2y still hanging out. 8y plus 2y is 10y. And then I add the 2 to both sides, just like I did on the last one. And I get 5. Be careful here, real quick. People who try to get in a hurry sometimes, or people who always want to be the first one to get the answer. will answer 2, but be careful. It's 10 times y, so you have to divide by 10. That is going to give me y equals 1/2. 5 over 10 is 1 over 2, 1/2. Remember, if you can't deal with fractions, if you're bad at fractions, use that calculator to help you. But now notice we have the y value. So if you want to try the next step on your own, go ahead and pause it and try it. But because I have the y value, I can take this now and substitute it back into that first step again, that first equation, and now I can get -1 plus 4 times 1/2, because I know y is 1/2. Please use the fractions as long as possible. Don't try to round decimals too quickly. So if we do that, that's going to give me -1 plus 2 equals 1. So that means x is 1 and y is 1/2. I want you to do a little thought experiment here. This is the same thing that we got over here, same kind of answer, consistent and independent, means it's going to intersect at one point. I think you'll think through this appropriately if you realize that a lot of problems that we do are going to have an answer. We're not going to have a bunch of infinite solutions and no solution problems anyways. But also think about the fact that because this is an uglier answer, 1 and 1/2, this is the reason we learn something other than graphing. Not just big numbers, but also just small numbers, these fractions, because you're not always going to be able to see exactly where those things touch. So it's going to be tough on you, and you're going to round answers incorrectly when this actually has a really nice answer. 1/2 is a nice answer. It's not pretty, but necessarily, your standards, but it is a nice answer. All right, so let's see if we can do one more. This time, Mr. Harrison is going to pick up the pace a bit. Yeah, let's do this one. Let's look at the Civil Rights Museum example, a little word problem. I'll help you get the equations. Like I said, I'm going to pick up the pace a little bit, and then I'm going to show you one of those weird kind of answers like no solution. This one says, in one day, the National Civil Rights Museum in Memphis, Tennessee collected $1,590 from 321 people. Notice that this is the total amount of money, and this is the total amount of people. This helps you set up a very common setup, kind of like Mr. Harrison's gym, the total amount of money, the total amount of people. It's a very common thing when you're selling things. So it says the price of each adult admission is $6. People with the ages of 4 to 17 pay the child admission, $4. Estimate how many adults and how many children were admitted that day. Again, notice here, let me lower this down a little bit. How many adults, how many children, that's my variables. So I'm going to have x plus y. The total number of adults plus the total number of children is 321. So what we did when we had Mr. Harrison's gym with 50 people. Adults pay $6, so $6 times the number of adults. We don't know how many came in, so that's what we're looking at. Plus $4 times y, or $4 times the number of children, equals 1,590. Now, again, you can set this up as a hypothetical, like I did with my gym, how many people I hope to get. But this one is, we're just trying to figure out how many people actually showed up. Now, I'm not saying that there's not other ways to do this. I'm just showing you that this is the same process that we did for my example as well. I was trying to aim for a certain number of people and a certain price. This one, we know what the price is. We know what the people are. We're just trying to figure out how many of each type of person came. Again, it can come down to marketing and sales that we want to know this type of thing. So, if we're looking at this, the graphing method, I think most of us would realize, would be really, really bad for this one. And so what we could use, or what we can use, I should say, is we can take this first equation right here, and we can get the x by itself by subtracting y. Why would I be able to do that, or why would I want to do that, even more importantly? is because I can solve for anything I want to. But now I have something that is equal to x, and I can use the substitution method to plug this back into that equation over here for x. Again, make sure you plug it into the other equation. That's a big key. So we plug it in where the x is, 321 minus y, plus 4y equals 1,590. And then we are going to distribute this and solve. So again, here would be a good place if you want to go through and try to figure out the answer before I do. Go ahead and stop here, pause here. I mean, you could have started all the way back up here. Sorry, I probably should have said that in the video. But we multiply this guy out. So let's see here. That's going to be 1926. Let's double check. Let's make sure. There's my screen recording device there. Let's go over here and make sure Mr. Harrison's not doing something stupid. Multiply that by 321. 1926. Good. Hey, Mr. Harrison can still do math. What is 6 times negative y? That's negative 6y. So now we can do negative 6y and positive 4y. That leaves me with a negative 2y. I'm going to kind of skip a little bit of steps or actually kind of move over to a different portion of the screen here. Not really skip steps. So you can see that over here. I'm going to subtract the 1926. So when we take it, again, 1590 minus 1926, 1590 minus 1926, we are going to end up with negative 336. So I'm going to come over here just a bit. Let me move my face around here. Hopefully it's not moving too crazy on your screen. Negative 2y equals negative 336. We divide by negative 2. We get y equals. And this is the reason we don't do this with inequalities, because obviously there'd be some dividing and flipping inequalities around and mess. We don't do this method with inequalities. We only do this when we are dealing with equations. Inequalities, we still graph those to find the solutions. So if we divide over here, we're going to end up with, what is that, 163. Let's make sure Mr. Harrison's doing decent math here. So let's put a parentheses here and divide that by negative 2. 168. Look at there. See, Mr. Harrison did a goof. What a dummy. 168. Okay, so if that is my y value, I can then take this just like I've been doing, and I can plug this into here and find my x value. 321 minus 168. Now, some of you might be saying, Mr. Harrison, can I just plug it in my head or use a calculator to do 321 minus 168? And that is absolutely fine. Okay, so if you want to go through here and not go through and have to type in everything in the calculator or whatever, or you just want to go straight over here to your calculator and do, okay, Mr. Harrison, I know that's going to be here, 321 minus 168. I know that's what it's going to be because there was 168 people that are the children, and I know the total was 321, so I know it's going to be 153 right here. Whatever, that's fine with me. Here's where Mr. Harrison's going to get picky. Go back to what we were doing. We're trying to find how many adults and how many children. Mr. Harrison's going to get picky here. You need to make sure you come back and say, okay, 153 was the X value. That's adults. 168, that was the Y value. That's children. Please, and real specific, there will be 4 to 17. I'm probably not going to grade you off on that, but if you don't actually answer the question, I will take off points. Because you need to make sure that you actually understand what the answer is. All right, last thing I'll show you real quick, and we'll be done. We'll keep this one under 30 minutes. Again, I'm sorry it's still maybe longer than some of you want to watch, but it at least is a little bit shorter than Mr. Harrison's normal rambling in class, right? Let's say we have y equals, let's go x plus 6. First of all, I want to point out here that if I've got x plus 6 right here, actually, Yeah, let's do that. X plus 6 here. Notice that that is already solved for y. That means this one is perfectly set up for the substitution method. So let's say then in the other equation we got negative 3x plus 3y equals 10. Just making something up real quick. If I do that and I plug this, like we've been doing, in for the y, because it's already perfectly set up for it. Guys, that's going to, like I said, that's going to happen. You're going to have some that are great for the substitution method. I'm going to go ahead and warn you ahead of time. The reason we have another method called the addition method is because sometimes the substitution method sucks. Okay? So if I plug that in right here, 3 times x, 3 times 6, you're going to end up with positive 3x plus 18 equals 10. If you look at these, negative 3x and positive 3x are just going to automatically cancel. Remember, that was already there. I didn't add something to both sides. I just looked at it. Those two are like terms, collected like terms. They're gone. That means there's nothing there but 18 equals 10. I can't say x equals something because x equals isn't there. So think about what that means. That means the x is canceled. Normally, when we had this back in the very first chapter, we said there would be no solution. Well, guess what? It's the same thing in this chapter. That just means these two lines, if you were to graph this first one and graph this second one, you would get two parallel lines. They do not touch each other because that would be the only possibility that has no solution. That means these two lines are what we call inconsistent, or they have no solution. This is the key. Yes, I'm happy if you remember that little inconsistent word, but I'm more happy if you know that this has no solution because they don't touch each other. They're not going to actually hit the same point. So you may be wondering, well, what's it going to look like if it does have infinite solutions like that other third one? You hadn't shown us one of those. That would look like everything canceling out, and it would be something like 10 equals 10, or 18 equals 18, or 0 equals 0. It would be something where everything cancels out because that would mean both lines are exactly the same line. All right, so that's the substitution method. You pick a variable, okay, step number 1, pick a variable, solve it. Take that you get for that variable and you substitute it into the other equation. Then you've got an equation like this red one here that is easy to solve for one variable. That answer plugs back in to find the second answer, like -1 plugs in to find 0. Same thing for this one. Same thing for this one. It doesn't matter how ugly equations are. Substitution works. So this substitution method is one that's very useful. Some people end up liking it the most. It's not my favorite. My favorite is the addition method because sometimes some equations are so ugly, even the substitution method's not fun. And so we'll look at another method tomorrow. Have a great day, guys.